Hello guys, welcome to Algorithms Made Easy. Today we will go through the day 18 problem from July LeetCoding Challenge course schedule 2. Please like the video and if you are new don't forget to subscribe to our channel so that you never miss any update. There are a total of n courses you have to take labeled from 0 to n-1. Some courses may have prerequisites. For example, to take course 0, you have to take course 1 which is expressed as a pair of 0, 1. Given the total number of courses and a list of prerequisites pair, return the ordering of courses you should take to finish all the courses. There may be multiple correct orders, so you just need to return one of them. If it is impossible to finish all the courses, return an empty array. This is an extension to the problem we have already made a video on. So do check out the video if you haven't viewed it yet and come back so that we can move ahead with this problem. There are two sample examples provided. We take the second one and see how we can solve it. This question is a classic example of topological sorting. A topological sort or topological ordering of a directed graph is a linear ordering of its vertices such that for every directed edge uv from vertex u to vertex v, u comes before v in the ordering. Also, topological sorting exists only when there is no cycle in a graph. While going through the problem, I noted down basic steps in order to reach the solution. Let's see them one by one. In the first step, we need to store the data in more meaningful format. What I mean by that is the input given is not properly structured. So we need to store this data in a format where we would have a relationship between the course and all its prerequisites. To achieve that, the first data structure that came to my mind is map. You can always use a data structure according to your choices. For now, let's move ahead with the map. The map will have a course as key and all it is prerequisites for as values. After iterating over the input array, the map will look like this. We can see it more clearly now that the 0 is a prerequisite for 1 and 2 and need to be completed first. The graph will look like this and is even more clear. The second step is just to check if the graph contains cycle or not. As we know that topological order does not contain cycle, we will first check that. Now to check whether the graph has a cycle or not, we will use two boolean arrays. We will now loop for all the courses and see if the cycle exists at any of those. Starting with node 0, we first check if the node is visited or not. If it is unvisited, then only we move ahead. We then update value at index 0 to true. Now as 1 and 2 can be reached from 0, we call our function on both. So now the temp node become 1 and we update value at index 1. Now from 1 we reach 3 and do the same. As now no unvisited node can be reached from 3, we backtrack to 1 and revert back its value to false. Same thing with 1 also. Now method on node 2 is called and we update value, and as 3 is already visited we backtrack to 0. We do this for all the nodes till either all nodes are visited or we found a cycle. As we have found no cycle, we are now sure that the topological order for this graph exists. Now let's see an example where cycle exists in a graph. Till node 1 everything remains the same. Now we traverse to node 3 and then from node 3 to node 2. Now comes this condition of cycle. We can reach node 1 from node 2, but as we can see that the node is already visited, we cannot revisit it. We also see that the node has been reached on this path in the past, so we know for sure that this path has cycle. Hence we cannot find topological ordering for it and we return an empty array. For the previous input, the graph does not have cycle, so we come to the last step, that is finding the topological order. We will use the same visited array, but this time we will have a stack to put our node into after the method call is finished. Starting with node 0 like before, we traverse the graph for all the nodes that can be reached. As 0 is unvisited, we mark it visited. From node 0, we move to 1 and 2. And from node 1, we have 3 as unvisited, so we move there. As now there is no unvisited node from 3, we push the node into the stack and backtrack to 1. Same thing will happen with node 1 and so we move to node 2. We can reach 3 from node 2, but as it has been already visited, we push 2 into stack and backtrack to 0. Finally, we push 0 into stack. Now we just need to pop all the values from the stack into an array and return it, which look like this. The time and space complexity is O of n. Here is the actual code snippet from the method. Also check out the link to the Java code in the description below. Thanks for watching the video. If you like the video, please like, share and subscribe to the channel. Let me know in the comment section what you think about the video.